Standard. Oop.
Hello everyone! Chapter 3, Learning Target 10, 3x3s. This is Miss Osier.
And Miss Lahar.
And here we go.
My favorite. This is my favorite.
These are fun.
Because it's like a puzzle, and you have to solve the puzzle. So up until this point, you've only done 2x2s. You know, systems of equations. You either graphed it, elimination method, or substitution method.
Correct.
In this case, the elimination method is going to be your friend.
Yes, we're going to start with that, with the 3x3, and then we're going to work our way down to a 2x2. So the steps are there. You know how to read. And here we go. So
Step 1.
this is a 3x3. What we mean by 3x3 is a system of 3 equations that contain 3 variables. So let's get rid of the most convenient variable.
Step 1 is to eliminate one variable in all of your equations.
So to do that, you have to break it up into 2 pairs. So I see a positive z and then 2 negative z's.
That's the winner.
So the game plan is to eliminate z, okay? Because as you can tell, I don't have any like 2s and 6s. They're not the same, 3s and 4s.
Yeah. I mean, I could work with those, but let's always try to make it easier on yourself. Use the one. If they have a 1 coefficient, go for it. Remember, you're looking for opposite signs in order to add them together to eliminate.
So we're going to again eliminate z. So when we say 1 plus 3, we're talking about like equation 1 and equation 3.
Yep.
So we're going to combine those and get rid of the z there. And then we have to also get rid of the z in equation 2. So you have to then choose 2 with one of the other 2. It doesn't matter which one.
So here's that math. We're going to add those 2 together, so that gives me a 2x2, 8x minus 2y equals 50. The z's have eliminated. That's what we wanted.
That was the purpose.
And then when we add 1 and 2, again, the z's eliminate, so we get negative 2x plus 5y equals 1.
Boom.
And now this is where it's review.
So now, yeah, you're down to 2 equations with 2 variables. You've done this before. So 8x minus 2y, negative 2x plus 5y equals 1. Here we have to think. 8 and 2 don't match, 2 and 5 don't match. So we have to make them match. The easiest one I can see is always going to be something like 2 even numbers, because you can usually multiply those real quick. So we're going to multiply the bottom by 4. That's going to create a negative 8x on the bottom, and then your x's will cancel out.
Yep. So you add those up, you get your y value, so you solve for y, and you get y is 3. So now you need to backtrack because you need to identify all 3 of those variables. So you can plug it into any one of your 2x2s, I think.
Yes.
So I plugged it into the first one. You could have plugged it into the other one, whatever works. Just do the math and solve for the other one.
Boom. Now that you have x and y, you can solve for z by substituting into any of the 3 original equations.
Yep. So plug it into 1. We're solving. So there's your solution, x, y, z. You can put, circle x equal yada, yada, yada.
Yep.
It's all.
Yeah, you can have the 3 separate answers listed, or you can put it pretty like this.
My advice is always to check your work once you get it.
Yep.
Okay?
And that's not hard.
Nope. So this is us showing the check. So basically all you have to do is just plug it in and make sure that it works for every single equation. So there's me checking it in the second one because we checked it in the first one. So and then there's me checking it in the third one. So it does check.
Yep. And we can also show you there is a faster way to define variables in your calculator so that you can just literally type in 2x plus y plus z and hit enter and see if it's 15. We can show you that if you're interested when the time comes.
Okay, so here's the next one, okay? And you've got to go slow with this, is my advice. Always check yourself.
I went fast. Hold on.
Oh, there's
slow. Go slow.
Go slow. Everything can come crashing down because you forget a negative or you add wrong. So just take your time. Don't rush these.
Yep.
So let's look at our variables to see which one we're going to eliminate. X's, I can work with that. But Y's, we got 4, 3, 1, 1, 6, 5, I see X's are the best, in my opinion.
Yeah. Now, when we say, like, start with X's, if you were thinking to start with your Y's, you're not wrong. You can start with any of the 3 variables. However, we're just trying to choose the path of least resistance, essentially. So game plan is to eliminate the x. I'm definitely going to add equation 1 and equation 2 because I don't have to do anything to those. However, equation 2 has this positive 2x. So I'm going to have to multiply one of the other 2 equations by 2 in order to eliminate that.
Because the third equation had a negative x there, that I chose that one to just multiply through by 2. So as you can see, I have negative 2x plus 6y minus 10z equals 22.
So this top equation is this third one multiplied by 2. And again, that would happen so that this negative 2 would cancel with that positive 2.
Okay, so then once we did that, we still had to get rid of the x in the other equation, that first equation that we didn't use. So I just took the first one and the third one and added them together.
Boom.
So now you're at a 2 by 2.
Once you're at a 2 by 2, you should be much more comfortable. This is nice. I see those 4s
I see those
stacking.
4s too. So I'll just have to take 1 and multiply it by -1 just to change the sign because you need them to eliminate.
So now that they're going to eliminate, we have 6y equals 12, therefore y is 2. Work it backwards, plug y into either of the 2 by 2's, meaning the variables, or the equations with 2 variables. Boom, boom, boom.
Oops, my animations were wrong. So the one on the left is me plugging it into the 2 by 2 to solve for the z.
And then once you have the z, you plug the y and the z into any of the first 3 original equations.
To get your solution.
Boom.
And you should always, I think this is me checking
Check.
this next slide. Let's hope for it. Oh, yep, there's me checking.
Check, check, check to check. Boom.
My animation's all over the place.
Look at us go.
Okay?
All right, that's it. Take your time. Have a wonderful day. We'll see you in class.